Hi everyone, so today we're going to be taking a look at something interesting. We're going to be taking a look at this small multimodal large language model, and it's called Janus. I think it's a Roman god or something like that, but it's basically a multimodal large language model that has the ability to understand and also generate images. As you can see down here, they explained all this. It takes in it has the understanding encoder and it has the text tokenizer. That means it actually accepts both image and also text, and at the end of the day it's going to produce the text. And we have on the right side here it's producing a generated image. That means it actually does generate image. This side is for the image generation and this side is for the image understanding. So it's really simple, but it has not been done before. I don't think I've seen any model that has the both of them, because usually they are separate. Like you can see something like Midjourney that does the generation, and also something like Claude Sonnet or GPT-V and GPT-O that actually accept images and text but don't actually generate it. So today we're going to be taking a look at this, and you can actually head on to the spaces here. You can just click on it and you go over to the spaces and you can actually try it out if you don't want to install it locally. But if you want to set it up locally, then you can actually follow the steps I'm going to follow today on this video. And it's pretty simple. We're going to go over to their GitHub repo, and if you go down here, you're going to see this link. And once you open it, you're going to get this page. And what we're going to do right now is clone this repo. And so we're going to go over to our IDE, and you can use VS Code or you can actually use PyCharm. It depends on what you actually have installed. And in this video, we're not going to be talking about how to set up a virtual environment. Well, make sure you do have your virtual environment set up. And so we have our projects open. We call the Janus 1.3B. That's basically the name. And I have nothing in it. So what I'm going to do right now is open up the terminal, and I'm going to type in git clone, and I'm going to put in the link, and I'll give a space and a dot. So it's going to clone it into this particular folder. Make sure you do not have anything inside this folder. Make sure you do not have even the configuration of the IDE you're actually using. Make sure you've actually wiped that. That will be hidden. If you're using PyCharm, it will be dot idea. So it's going to be hidden. Make sure it's cleared. That's if you want to do it the way I'm actually doing it right now. Or you can just clone it into whatever folder and open the folder as the project folder. But this is what I'm going to do. Okay, let's run it, and it's cloning. So now that this is done, we can go back to the Hugging Face page to get all the necessary files we need to get this working. But you can also just work with it like this, and at the end of the day, it's going to download the files automatically for you, and you to send it over to your cache directory if you're using a Macintosh or OS X, sorry. And if you're using that, it's going to send it over to your cache directory, since it to download from Hugging Face Hub. So you won't have any problems with that. That's if you want to use it that way, or you can actually set a different cache directory so you to just send it to whichever directory you actually want it to be saved in. But for this video, I'm going to be setting it up how I always set up everything locally. I'm going to download all the necessary files from Hugging Face directly, and I'm going to put them in this project directory. And the folder I'm going to create is models. Create a new directory, we'll call it model. And that's where I'm going to paste all the files we actually got. So if you go over to the Hugging Face page, you have to go to files and versions. That's where you need to go, and you can download all the necessary files. You can also download the README file if you want to actually view it in your IDE. You need to download all the JSON and the safe tensor files. That's really important. All the files that have .json and also the one that has the .safe tensor. That's what you actually need to download. Make sure all of them. Let's say from this one to the bottom, you can ignore the teaser.png. It's one of the files that you need in the readme, but you can, if you want to get the readme, then just download everything here, and you can ignore the git attributes. And the moment you're actually done downloading it, then you can copy everything to the models directory. And since I have downloaded mine, I'm going to copy all the files I downloaded into that directory right now. Now I've actually got everything in here. We can actually continue, and if we go over to inference.py, inference.py is a file where that actually does the basic inference. That's for the image understanding. If you want to send an image and a text over, and it's going to, the LLM is going to end up generating a text if it actually understands the image, it will tell you what the image is based on the instruct or the text you actually gave it. And the generation inference.py is actually used to generate images just like Midjourney and DALL-E, and that's what you need. You can actually check out the file if you want to, but for this video we're going to be working on the inference first. So to actually work with this file, I'll have to install the necessary requirements from requirements.txt, and to do that we'll run a command pip install -r requirements.txt. And before I actually get to that, I'm going to have to set up my virtual environment, and it is actually recommended to use a virtual environment, so everything will just go in there. All your packages and everything you need for this particular project will go in there instead of installing it directly on your PC. Now I'm going to set up mine, and I'm going to be using virtual env. You can use Conda or whatever you want, but for this video I'm going to be using virtual env. So go ahead and set up yours, and I'm going to do that for my project. And I have actually set up my virtual environment, but it has not been activated. And since it hasn't showed up here, I'm going to have to close this terminal and open it up. As you can see, it's activated. Now we can actually run pip install requirements.txt. And as you can see, it ran into some problems. It says could not find this version. And if we go over to requirements.txt, we can actually remove the version basically, since that version does not actually exist. Or you can actually use greater than sign to signify that you need a package or a version of Torch that's actually higher than that or equal to that. So I'm going to change this version of sentence speed. Since I actually ran into an issue, I'm going to change this version to this, and I'm going to run it again. Okay, now that that's installed, the next thing I'm going to check out is inference.py. But just a quick note for the sentence speeds, the reason why I upgraded the version is because I'm using 3.12. If you're using maybe a different version of Python, you might not actually need to do that. But since I'm actually using 3.12 for my virtual environment, that's what I had to do. So let's go over to inference.py. Now, as you can see, all our imports are fine. And now the next thing we're going to have to do is change the model path, and as usual we give it models. And another thing we're going to have to add is use local files only through. So I set the local files only to through, so it doesn't go and download the model. So even if it doesn't find it, to just throw an error. So that's what I want. And I'm also going to add it here. Now, the next thing we're going to have to do is take away anything that has to do with CUDA. And another quick note is I'm actually running this on my MacBook Pro, and I want it to run on my CPU. I am not actually setting this up on the Windows that actually have access to maybe a graphics card like NVIDIA that can enable me to use CUDA. So I'm going to change all this to CPU. And anyway, they actually mentioned CUDA, I'm going to have to, okay. There's no mention of it anymore. And since there's no mention of it, we're fine. And the first thing it actually shows is this images equation, convert the formula to latex code. And we can actually run this now and see how it actually does. But before we actually do that, let's go over to the images directory and look at the equation.png, this file. Okay, this is what it's actually saying to convert to latex code. So let's run inference.py. So I'm going to speed this up till when it actually provides an answer. So let's go. So now we've actually got our answer. Let's copy this and let's paste it in a latex to image converter. And that is what we get. And let's compare it to the image. Okay, A0. This one 3/4, this Q1 over 9, so it's really correct. That's pretty good. Now let's go over to the next test, which is, okay, let's change this to Doge. So I said interpret this image as accurately as possible, and I think it's a meme, so let's run it again. And we've actually got an answer. So it said the image is a humorous comparison between two different types of visual encoding methods. On the left side, there is a depiction of a muscular dog with a shrug expression, which is a common visual encoding method that represents a no or no effect. In the context of visual data, this method is often used to indicate the visual data does not have any significance, meaning or effect. On the right side, depiction of a sitting dog with a shrug expression. Okay, it's actually got the animals, and it's actually got that it's actually a meme, which is good. The coupling is got the text, and we have what other thing? Let's see if it got the second text. Okay, it got the second text. Single visual encoder. That's good. And for our next test, we're going to be using iPhone.jpg, and that's what we're going to send over to the LLM. And for the test, it's going to tell us what app is actually consuming more memory and the memory size. So let's send it over to the LLM and change this to. Okay, we've actually changed it to iPhone.jpg, and we've asked it what app is consuming the most amount of memory and what's its memory size. So let's run this again. So it actually got it wrong. It said the app is Picat. I think it's trying to say pictures or something. It's consuming the most amount of memory with a memory size of 474.2 megabytes, which is wrong. If we go back here, you can see Pixart is, it actually said you didn't even get the memory size correctly, and it didn't even get, like, I think it doesn't understand images that well, and I don't know what I actually expected. It's a 1.3 billion parameter model, so that's just basically expected. Now next thing we're going to have to try is the image generation. We're going to see how good it is. We're going to try out 3 different prompts, and we are not going to be using the local one for this because it takes a very long time to generate an image. It doesn't really consume so much memory because it doesn't slow down my PC or anything, but it just takes a while, like a very long time. For some reason, it takes a really long time to generate an image locally. So we're going to be trying out the one that's actually hosted on the Hugging Face Spaces, and let's go over there. But before we do, just so you know, if you want to use this generation underscore inference.py, make sure you do make all the changes we made in the inference.py. You can just add the local files only. You can add that argument here and also here, and you change this to CPU if you want to run it locally, and look for any path that actually has CUDA, and make sure you do change it to CPU, like here and also here. So if you want to actually run it on your CPU and you do not want to run it on maybe an NVIDIA graphics card, then make sure you do change it to CPU. So before we actually check out the Hugging Face Spaces for our next test, we are going to check out the web UI. It's inside the demo folder, and it's called app.py. And once we open this, let's make some changes so we can actually run this on our CPU and locally. We're going to add the local files only, same thing we did earlier. And once you've done that, you can change this to CPU. And we're also going to scroll down and remove this. Okay, we also need to change this, the model path, to models, and we're fine. Now let's run it. We're going to call python-m demo.app because it's located in the demo directory, and we are calling the app.py. So let's run this. It should generate a local URL, and once that's done, we are going to open it up in our browser. Okay, the URL has been generated. Now let's visit it. And all we're going to make use of in this video is the top part, which is the multimodal understanding, and the bottom part is text to image generation. We won't be using this part. We are going to be using the Hugging Face Spaces for the image generation because it takes a very long time to generate images on my CPU, but it might work perfectly fine for you. It might not take as much time if you're using something like NVIDIA, but I don't know why it takes a very long time. It doesn't freeze my PC, it just takes a very long time, and I don't know why. But let's just select an image and we're going to pass in a question. Or we could just click on one of these that's already here and we could send it. Now let's wait for a response. Okay, we've gotten a response. This meme compares two different types of neural networks. Okay, so now that we know the web UI actually works and we've done previous tests on the image understanding, let's go over to the Hugging Face Spaces for the image generation test. Okay, now we can actually click any of these examples. These are example prompts that they actually gave it to generate images, but we're going to have to send in our own text and we're going to put the prompt here and we're going to generate the images. So let's pass in this prompt and let's generate. Okay, it's actually done, and the prompt we actually gave it is golden retriever puppy with a playful expression sitting in a grassy field, and this is what it actually generated. Okay, okay. This one is kind of damaged. Not bad. It looks weird, but this one is much better. This one is much better, I think. This one is much better because the teeth looks okay. The teeth looks weird, but we'll take it. And this is the defected one. It's not bad. Another one I'm gonna try is young woman with curly hair and freckles in soft morning sunlight wearing vintage clothing. Let's generate. And it's done. And let's check it out. It's really weird. The position of the eyes. Uh, Position of the eyes, face. The position of the eyes is it's crazy. I don't know why it's making that mistake, but that's expected from a 1.3 billion parameter model. Okay, this is majestic white tiger in a lush jungle, glowing blue eyes, intense gaze. Okay, this is weird. The mouth. This is manageable. This one is not that bad. Manageable. Also manageable. Okay, and that's it. So basically our test is done. So for my final thoughts on this model, I do think it's an impressive model for its size. It's just 1.3 billion parameter and it can actually do both understanding and also generation of images, which is really cool. But I do think it's a proof of concept or something. That's, in my own opinion, I think it's just a proof of concept because it's really small, and for it to actually perform better, it actually needs to be something like 8 billion or 11 billion parameter model, but they just did a 1.3 billion parameter model. And I do think in a few months we might see a model that actually does both image generation and also image understanding that's much larger than this one and also performs better. That's in my own opinion. And also, I do think it's actually horrible at OCR because when we gave it the iPhone image, it failed to actually give us the name of the app, basically, and it chose the wrong app. And it also gave us the wrong size, storage size. So that was basically a fail. But it actually performed better when it comes to image generation, apart from the eyes and all that. It didn't place things where they were supposed to be. But like I said, maybe this is just a proof of concept, and for the size, maybe we shouldn't be that hard on it. And you can check it out and also play around with it. You can play around with it locally, or you can actually come to your Hugging Face spaces and just check it out if you want to. And that's going to be it for this video. So thank you for watching, and make sure you do like, subscribe, and share. Make sure you do subscribe, and also make sure you hit that bell icon so you're going to receive notification whenever I release a new video. It really helps a lot as we strive to get to our first 1,000 subscribers. It really helps a lot. So make sure you do subscribe if you haven't, and thank you for watching. Have a nice one.